Alright, so the problems today are essentially going to have a lot of similarity to the problem that we did yesterday and the problems you did for homework. The problems today are just word problem based. So this first one says Susie is pulling her brother Bobby in a wagon using a force of 50 newtons. Which angle should the handle be at for the best result? 25 degrees or 55 degrees? So we are going to draw two problems here and figure out what's going on to just figure out which one is actually best. So we have two vectors. They're the same force, so the same length, the same magnitude, but one's at 25 degrees and the other one is at 55 degrees. And we're trying to figure out which is the best result. So this is where you have to think a little bit about what that means in terms of pulling a wagon. Does that mean we're looking for a horizontal value or a vertical value? So hopefully what you realize here is when you're pulling a wagon, you're trying to pull it horizontally. So we're looking for the horizontal value. So for these particular ones, we don't need to solve the whole triangle. We're just going to solve for the horizontal value. I'm going to call that x1. And then in the second scenario, we're going to solve for the horizontal value. I'm going to call that x2. So since we're trying to find the horizontal component, right now we're going to use cosine. So it'll be cosine 25 is equal to x1 over 50. Multiply both sides by 50. Bringing it x1 is equal to, when I type that in the calculator, I got 45.32. And then we're going to solve for x2 in the second triangle. That's also going to be cosine, but it'll be cosine of 55 is equal to x2 over 50. Still multiplying both sides by 50. We end up with x2 is equal to 28.68 when you type that in the calculator. So again, the idea is which one of those is the best result. The best result is going to be the one that goes the farthest, which means it has the biggest horizontal number, which would be this one right here. So to answer the question, we are going to answer it in words here. I would say that the 25-degree angle gives the best result because it goes the farthest. Okay? Let's try the next one. So this one is very similar to the ones we were doing yesterday, but now there's words that go along with it. So we have three dogs are fighting over a toy. One dog is pulling, at 15 newtons at 40 degrees. The second dog is pulling at 12 newtons at 120 degrees, and the last dog is pulling at 8 newtons at 305 degrees. What is the magnitude and the direction of the resultant force? So just a quick sketch before I'm going to draw them separately, but if these were together right now, you'd have one dog pulling this way, you'd have one dog pulling this way, and we have one dog pulling this way. So they're all three pulling on this toy, all in different directions, and we want to know one of them. If you've ever seen dogs pull on a pull toy, there's usually one that's stronger and the toy gets dragged in one of the directions. So is it going to drag this way? Is it going to drag this way? Is it going to drag this way? What's the result? So to do this, we're going to do them separately though, because it's going to make it a whole lot less confusing, hopefully. So I'm going to draw three separate pictures. So here's my first picture. That's going to be at 40 degrees, pulling at 15 newtons. I'm going to make my triangle. And then my second picture is at 120 degrees, so it's in the second quadrant. And that's at 12 newtons. And then the third picture is 305 degrees, which is going to be in the fourth quadrant. Draw my triangle and fill in that that's 8 newtons. And we're going to find all the horizontal components, x1, x2, x3, and all the vertical components, y1, y2, y3. So to find the horizontal components, that's going to be cosine. So I'm going to do this the shortcut way. 15 times the cosine of 40 gives me that x1 is 11.49. Then we're going to move and find x2. x2 is going to be 12 times the cosine of 120 degrees. x2 ends up being -6. And then x3 is going to be 8 times the cosine of the angle 305 degrees. x3 ends up being 4.59. And then we're going to find the y values in each of the pictures, the vertical components. So y1 is going to be 15 times, y is going to use sine of 40. y1 is 9.64. Then we're going to find y2, that's going to be 12 times the sine of 120. y2 is going to be 10.39. And then y3 is going to be 8 times the sine of 305. y3 is going to be -6.55. So then from there, we're worried about what the result is. We want the resultant force. To get the resultant force, I'm going to add all the x values together. I'm going to add all the y values together. So I'm just going to write this a little differently than yesterday. I'm not going to write all the components out. I'm just literally going to bring all those x values down, add them all together. That'll give me the resultant for x, which is 10.08. And then I need to find the resultant for y. I'm going to add all those y values together. 9.64 plus 10.39 plus -6.55. We get 13.48. So that means my resultant vector right now is 10.08, comma 13.48. The nice thing is those are both even numbers, so finding the angle should be really easy. We're trying to find the direction and the magnitude. Those are the two things that it asked for in the directions. So the direction, remember, is the angle. It's going to be tangent theta is equal to, it'll be y over x. And you'll do tan -1 on your calculator, and it will tell me that that is 53.2 degrees. And then you also have to find the magnitude, which is just using Pythagorean theorem. We're going to do the square root of 10.08 squared plus 13.48 squared. And that ends up being 16.83. So those are the two answers to the question. Just make sure if you had a negative number in your resultant vector that you would have to think of how that's going to affect the angle. If you needed to draw it, we could do a little sketch here of the one we just found. It's over 10 up 13. So you can put those numbers in if that helps you to be able to find theta and find the magnitude as well. But this was in the first quadrant, so I don't have to do anything to theta. If it's in any other quadrant, you're going to have to think about what theta would be in that quadrant. All right, check Schoology for everything else that I need you to do in terms of checking your homework from yesterday and getting me which one do you have questions on. Enjoy the rest of your day at home and stay warm.